Okay, the first thing that we're going to do is do question 1e, the excellence question. And you have a curve, and it's a positive cubic. So it's always nice to sort of get a sense of what you're dealing with. And you've got a tangent to the curve, and they're giving us the equation of the tangent to the curve. So basically, there's the tangent to the curve. It doesn't really matter where it is, and you don't have to draw it, exact. What they want to do is they want us to find the coordinate of the point where the tangent hits the curve. So that's the gradient. It has to do with gradients and tangents and so on. So we know we're going to differentiate. So to differentiate this, we just get 3 over 2x squared plus, or minus 2, minus 2. And the other thing I'm going to do is I'm going to take this equation and I'm just going to make it so that I can see what the gradient is for that tangent. Because remember, if my gradient function equals a particular gradient, that means that I can find x. So I'm just going to rearrange that, and I'm going to get y is equal to negative 1/2 x minus 6. That's just that equation rearranged. Now, what I do know from rearranging is that this is my gradient. And that's basically what my gradient function is going to equal. And if I can take my gradient function, which is this, and make it equal negative 1/2, then I can basically work my way through and basically solve for x, because that's what I've got to do. I've got to find, I've got a coordinate here system, and I've got to find what that x value is there, and also the y value. But right now we're just going to work on the x value. So I've got 3 over 2x squared is equal to, and it's going to end up being 3 over 2, and then x squared is equal to 1, and then x, now this is important because we're going to take the square root of 1, which is plus or minus 1. We've got 2 answers for x. Well, it can't be 2 answers for x, so we're going to have to figure out which one of these values is going to work for that particular tangent line. So we're going to have to work our way through it. So what we then have to do is take those values and stick them into our function, the original function, and test to get a y value, and then test to see if which one of these actually works, because they're not going to both work. So we'll test one, and we'll substitute 1 into that, and when we substitute 1 into that original, we get negative 8.5. And so we now have a point of 1 and negative 8.5. And then we've got to test negative 1 into the original equation. And when we work that out, we'll end up getting negative 5.5. So we have negative 1 and negative 5.5. It can't be both these answers. So we've got to figure out which one of these. Is it this one or is it this one? So the tangent has this equation. And one of those points satisfies this equation, but only one of those points. So we have to test them and put them in. And the only one that works, so if I do this, I'm just going to put negative 1 for x plus, and I'm going to put in y, which is 2 times negative 5.5 plus 12. Now if I work that out, I get 0 is equal to 0. It works. If I test the other point, it will not work. So this works. So the coordinate that I'm looking for is negative 1 and negative 5.5.